All right, today we're diving into a story that's been 200 years in the making. We're talking about a famous mathematical problem, a door that was basically slammed shut and locked, and a brand new key that might just open it. Let's get into how a problem once called impossible was finally solved. I mean, just think about that for a second. Imagine being told for 2 whole centuries that something is fundamentally impossible, that there's a hard limit on what we can figure out. And then someone just waltzes right past it. That's really the heart of the story we're exploring today. So to really get what a huge deal this is, we've got to rewind the clock. We need to go back to the moment that door was locked in the first place. Because this isn't some new puzzle. It's one of the great historic roadblocks in all of mathematics. For a long time, progress was moving along just fine. Back in the 1500s, mathematicians found general formulas for equations up to the fourth degree. But then, in 1824, a guy named Niels Henrik Abel proved something absolutely staggering. There is no general formula for solving polynomial equations of the fifth degree or higher. And just like that, for over 200 years, the entire world had to fall back on just making approximations. Now here's the thing. The really crucial part is in the fine print. Abel's proof was super specific. He proved there was no general solution in radicals. All that means is you couldn't find the exact answer using just the standard toolkit, adding, subtracting, multiplying, dividing, and taking roots. That very specific detail, that was the lock on the door. And this wasn't just some small little hurdle. No way. This quote really says it all. Abel's theorem basically shut down an entire field of research. It was just accepted as a fundamental limit of the universe, a sign that exact answers for these complex equations were simply out of our reach, period. So, if you can't get an exact answer, what do? I mean, how did science and engineering keep moving forward? Well, they got clever. They came up with workarounds. But those workarounds, those approximations, they came with their own huge set of problems. See, approximations are basically just really, really good guesses. But they're still guesses. They get you close, but they always introduce these tiny little rounding errors. And the scary part is, those tiny errors can cascade and grow into gigantic mistakes. That's what we call numerical instability. You can't get a pure, perfect algebraic answer. And for the really, really complex problems, these methods just completely fall apart. And for 200 years, that was a trade-off everyone just had to live with. But what if you didn't have to make that trade-off? What if it was a false choice all along? Let's jump to the present day, because this is where the story gets a crazy, incredible twist. This is where a new kind of key shows up. Then in 2023, this happens. A mathematician named Morad Sultan Ezwedi introduces a theorem that does the very thing everyone said was impossible. It gives us a way to find the exact, symbolic, perfect solution for polynomial equations of any degree. Not an approximation, the real exact answer. Okay, so this is the really clever part. Ezwedi's theorem doesn't actually break Abel's theorem, it just sidesteps it completely. Remember how Abel's proof was only about solutions in radicals? Well, Ezwedi's method uses a whole new, more powerful toolkit. It's not breaking the old rules, it's playing an entirely different game. So you're probably thinking, how on earth does this actually work? We're not going to get buried in the formulas, don't worry. But let's kind of pop the hood and take a peek at the engine that's driving these incredible answers. Okay, check this thing out. This is the monster we're trying to solve. A 19th degree polynomial. I mean, just look at it. To any mathematician before 2023, finding an exact solution for this was a complete non-starter. You'd have to guess. But with Ezwedi's theorem, it's just a systematic process. Now, it might sound impossibly complicated, but the core idea is actually pretty elegant. You can think of it in 3 main steps. First, you define a new set of values based on the original equation. Second, you use this special formula, this engine, to calculate these new values one by one, step by step. And finally, you use those perfectly calculated values to build the exact answer. And this engine just works. It's so methodical. It starts at step 1, does a calculation, gets a precise result. Then it moves to step 2, uses the last result to get the next one. It just keeps chugging along, step after step after step, building the solution piece by perfect piece. And that right there, that's the magic. Because the whole process is purely symbolic, there's just no place for those pesky rounding errors to creep in. There's no guessing.
Each step is exact, building on the last with perfect precision. It's basically constructing the final answer piece by guaranteed piece.
So, we've run the engine. It's done all the hard work. What comes out the other side? Well, this is where that locked door isn't just unlocked, it's blown right off its hinges. A whole new era of solvability is here.
I mean, just look at this comparison. The difference is night and day. The old methods hit a brick wall for exact answers at degree 5. Euclides' theorem handles any degree you throw at it. The old way gives you fuzzy approximations with potential errors. The new way gives you exact, perfect expressions with zero error. It's a fundamental shift from a limited system to a universal one.
And here it is. This is it. After all those steps, that giant, messy 19th degree polynomial, it all boils down to this. This is the exact symbolic answer. It's not a long, messy decimal approximation. It's the algebraically perfect solution, something that just a short while ago was believed to be impossible to find.
You know, there's something just so poetic about this. This isn't just about crunching numbers. It's about revisiting a 200-year-old landmark in the history of thought and realizing that the boundary we all accepted, well, it was never quite what we thought it was.
And honestly, that's the idea that should really stick with you. This whole story isn't just a cool math trick. It's way bigger than that. It's a philosophical statement. It tells us that impossible is often just another word for we haven't invented the right tools yet. Think about it. This one idea, this new key, opened a door that was shut tight for 2 centuries. It really makes you wonder, right? What other impossible problems are out there right now, in science, in medicine, just waiting for someone, somewhere, to invent a new kind of key?